So let's look at the question. Third maximum number. As the description said, they are given integer array lambs. We need to return the third distinct maximum number in this array. If the third maximum number doesn't exist, we just return the maximum number, the first maximum number. So the first example is give us first distinct max number is 3, and the second is 2, and the third is 1. So we just return 1. And the second example, the first distinct max number is 2, and the second is 1, and because the third distinct max number doesn't exist, so we just return the max number. It is 2, right? And the third example, the first max distinct number is 3, and the second is 2, because the two have counted together since they have the same value, and the third distinct max number is 1. And the approach, this time we will use very intuitively approach. We just use a set and delete the maximum number. And as the question they give us a restriction, we can only use O of n solution, so we can't sort it valued and then select the third to the end one, because the time complexity of sorting is O of n log n. So and this problem clearly states that our solution must have a time complexity of O of n though. So let's implement the code in the Python. First, we will use this as our example to show how it is worked. And so as the program, as the description say, the duplicate should be ignored, and we need to find the third maximum distinct value, and the input array have a duplicate. To handle this, to remove this, we have to convert the input array into a set. Is a mathematical concept to remove the duplicates in this array. So maybe you can build your own function to loop through the list and keep track of the maximum thing so far, but it is not necessary, because while in Python we have this function in the library to use to make a set. Just make a set in the input lambs, and so this time we just overwrite the lambs into a set. This will converting our input array to a set, and so put every input values to a hash set. But this will cost O of n times, and about the space it will cost let's see, it will cost O of 1 place to store, and n is the length of the array. But in the worst case, the hash set will keep the same size as the input array. So it may be in the worst case, it will require O of n space to store, and then we convert into a set. After we convert it to a set, we can now keep finding the max number. The maximum is max of the lambs. So print. So it is 12. The max number now is 12. So, and we should keep consider if some edge case, like if the third maximum doesn't exist, then we need to directly return the max number of the original array. So we should check whether or not the edge case is here. We can detect this situation as soon as we convert the input array to a set, because it will in this case it will contain less than 3 elements. So we can use the length of the lambs now. Lambs is overwriting into a set now. if it is less than 3, we can just return the maximum, because this is the question description ask us. And otherwise, it is a normal case, general case. We should continue to find in the third maximum lambs dot remove. Just remove the maximum we just found here, right? We just found here. Because we found the maximum deleted. This is the first maximum we deleted, and so after we deleted, we will so the 12 now will be deleted. Yeah, so the 12 now it will be deleted from the hash side. And remember, deleting a value from hash side have only cost of O of 1 time, so we can ignore that. Yeah, and let's find the second maximum. Is the maximum of the names, because it overwrite is already removed the first maximum. We need to find the new maximum, and the second maximum is 9. So this time the 9 is the left maximum in the array, and it will also be removed. Lambs dot removed dot second maximum. So this will delete the line, and because we find the second maximum is 9, we just follow the same process as we did before, right? And 9 is deleted, and then we just return the reminder names. This will remember the newest maximum. The reminder maximum is it is the third. We can return the left maximum, which is the 8, is the answer of this case. So let's build a function for this. Class solution define third max self lambs integer array, return enter, and give them an indentation and another indentation. We can print out our result here. Print solution dot third, and we can get our result. It is 8, and so finding the maximum in the hash set has a cost of O of n time, and all the value lead to a loop through, and we also did this 3 times, so this will waste of O of 3 times n. It is O of n, as we can drop out the constant in big O notation, and the result is A. And so in totally the time complexity is O of n plus O of n, and it is also O of n time complexity. In the previous approach, we just deleted the maximum and the second maximum so that we could easily find the third maximum. We had converted the input array into a set, so that duplicates won't be super complicated to handle, right? Instead of deleting the item though, we could instead keep a set of maximum we have already seen. Then, when we are searching for a maximum, we can ignore any value that already in the same set. This will also handle duplicates very elegantly. Like the example here, we have a input set. The first value we like to put into the same max set would be 12. Then, when we find the second maximum, the algorithm will know to ignore all the 12s. the time complexity is still O of n, because for each of the 3 times we find the next maximum, we need to perform an O of n scan, because there are only at most 3 scans. The total time complexity is just O of n, and all the set operations are O of 1, because there are only at most 3 items in the set. And the space complexity is just O of 1, because the scene maximum can contain at most 3 items, so the space complexity is just only O of 1. So let's try to implement the code in the Python. First, we have to define a function to how to ignore the scene, the element we have seen. Define a maximum underscore ignoring scene maximums, and the parameters is names and the scene maximums. And so the first we initialize the maximums is none, and because the first is nothing, we just use a for loop to iterate every element inside it for lem in lems. We just if lems is in the scene maximum, we just continue if it is in. But if it is not, if the maximum is none, or lem is bigger than maximums, so this time, because it's less than the 3, we just the maximum is just lems, and we return after we iterate every element. And so then the scene is a set, is an empty set. We use a for loop for underscore in range 3. We iterate 3 times. Current underscore maximus is a maximum, don't ignore, and the lems and the scene underscore maximus, and if current maximum is none, we just return the maximum scene, and the scene underscore maximum is add to the current maximums, and we can return after we just pick the smallest, and this is inside the bigger one, so we can define a third maximum self nums is a integer list, and return an integer, indicate an indentation. So far, through the input array, our approaches have required multiple parsers. Well, this is still O of n in big O notation, but it would be good if we could solve it in a single parse. One way is to simply use a set to keep track of 3 maximum values we have seen so far. Well, you could achieve this something similar by using 3 variables like maximum, second maximum, and third maximum, but it is messy to work with. It is a poor programming practice. For each number in the array, we just add it into the set of maximum. If this causes there to be more than 3 numbers in the set, then we evaluate the smallest number. and at the end, we check whether or not there are 3 numbers in the set. If there are, this means the third maximum exists, and it will be the minimum in the set. But if it is not, this means there was no third maximum, and so we should return the maximum of the set as per the program requirements. So the time complexity is O of n. For each of the n value in the input array, we insert it into a set for a cost of O of 1. Then we sometimes find and remove the minimum of the set because there are never more than 3 items in the set. So the time complexity of doing this is also O of 1. So in total, we do this n for n elements, so we leave the O of n. And about the space complexity is just O of 1 because the maximum never holds more than 3 items at one time, and it is considered to be the constant of O of 1. Let's try to implement the algorithm in Python. First, we have an example input array here. It's easy to demonstrate, right? We create a variable maximum. Maximums is empty set as we show it to add 2 lambda inside it, and we have a lambs, so we can use a for loop for lambs. In lambs by every iteration, it will add element inside it. The maximums dot add the lamb. So every time it will add lambs by each iteration, we just can print it out in our maximum, so it can show every time it add to the empty set, except the duplicate one. It's automatically removed, or as we say, ignored, and we can use if it is bigger than the 3, we just remove the maximums is bigger than 3. If it is bigger than 3, we just remove the maximum dot remove. What we should remove is the minimum. Yeah, I mean the fourth of the minimum of the smallest element we just removed. So I can print it out. Yes, it will every time it will automatically remove, and so we did it. So we already did it, but we have to remember to if the length is maximum is 3. That means we finished. After we finish the for loop, we have this, right? As we can show, we can print the maximum here, and after we finish, we get the last one. After we finish, we just use this to judge. It will automatically return the meaning of the maximum. So this time, because it's only 3 elements left, so we just return the smallest. Otherwise, in the edge case, in the final, we can see the edge case. If it is less than them, we just, if it is less than the 3 elements inside it, that's such as 2 element or 1 element, we just return the maximum. So we did it. Let's get define functions. Third max self names is integer list and return integer, and class solution and integer, and we use this to print them out. Print solution dot third print them out. Yeah, it works, and we can remove here. The answer is 15 as we diagram showed before.